What's that first word? Parentheses. That basically means look on the paren. If I could almost spell it, that'd be good. Parentheses. So you're looking on the inside. So which part should we look at first?
-1 minus 2.
Yeah, what is -1 minus 2, everybody? -3. And then down on the bottom, is that the square root of 9 times -3?
Yes.
What is the square root of 9?
3.
3. So let's just pause here and rewrite it. -2 times 3 minus -3 plus 2 all over what? 3 times -3. What's minus -2 mean? What's plus 2? Plus 2, exactly. Very nice. Okay. So now we still have some parentheses to deal with. We have -2. What does the top turn into? Minus -3. What's that mean? What's 3 plus 3 plus 2? 8. All over. What's 3 times -3? Plus 2. So what's -2 times 8? Over what? -7. Negative over negative is a? So you have 16 over 7. Yeah, so this. No, absolutely. This right here. Sure. That's fine. There's nothing to solve. There's no equal sign. All you're doing is simplifying. There is no equation here.
Okay, so I just leave it like that.
There's nothing to solve. Exactly. Good. The kind of the core aspects that you already went over. The main thing you need to know about all of these, the names. The names. So the distributive property, A times parentheses B plus C, you distribute across. Identity properties. What does identity mean? Well, no, not mathematically, but what is the general definition for identity? Who you are, yourself, right? So the additive identity, what can you add to something so you don't change it, is 0. What do you multiply by so you don't change anything? 1. Identity, self, same. Inverse, additive identity. So you add to it to get 0. The opposite of A is negative A, because when you add them together, you get 0. Multiplicative inverse is what you multiply by to get 1. So the inverse of A is going to be multiplicative inverse is 1 over it, which in this case only, it's the same as the reciprocal. The commutative and associative. Commutative, what does this tell you? If A plus B is equal to B plus A, that's true. What does that tell you? What lesson does that tell you? Devo? What does it tell you? Yeah. Order for addition doesn't matter. Is that always the case in math? No. Can the order matter a whole lot? Absolutely. And then there are a whole other types of math where order almost always changes it. You'll learn maybe a little bit in this class if we have time about matrices. When you can multiply a matrix times a matrix. It looks like a grid of numbers. If you multiply one matrix by another, but then you switch the order, it usually, almost always, changes the answer completely. And here's something that's interesting. Sometimes in matrix land, you can multiply A times B, but B times A isn't even defined. Crazy. And then for multiplication, you have your associative. Well, so you have associative, which essentially says if you have A, B, and C, it doesn't matter which ones you add together first. No, it doesn't. But this is what we're really going to spend most of our time with today, equations. And the big question is, what is an equation? Can someone give me the simplest definition they can think of for an equation? What is an equation? Anybody? What is an equation? It's right there in front of you. Yeah.
It's something that equals something.
Yeah, we got it. It's mathematical expression with what? Yes, with an equal sign. Can that other stuff, can that be a ton of different things? Absolutely, but what does it have to have? Have to have an equal. If it doesn't have an equal sign, it can't be an equation. What do you see at the beginning of the word equation? Two things are equal. We're specifically going to start with linear equations in one variable, meaning there are how many variables in the equation? In this case, what's the only variable here? In this equation, what's the only variable? X is a variable. Everything else are constants. And what types of constants are they? What kind of numbers are they? Real numbers. So if you have an equation and you can rearrange it to ax plus b equals c, it is a linear equation in one variable. So what's another, give me one specific linear equation. Someone just come up with one, yeah. Nope, because we're doing single variable. Give me one linear equation with numbers. A can be anything, B can be anything, C can be anything. Someone give me one of them. There's an infinite. What? No A, B, or C. I want numbers. 4, well, I need a full sentence here.
4x
Yep.
plus 8 equals 2.
Sure. Is that a linear equation in one variable? Yeah. You have a real number, a real number, and a real number, and the variable x. There's no second variable. Are there linear equations in two variables? Yes. You've all dealt with them a little bit. And we're going to attack these. We're going to analyze them. We're going to simplify them. What about the golden rule of algebra? The golden rule of algebra. You might have heard this before. What's the golden rule in general? Anybody know? What you do on going to you, right, exactly. So the idea here for algebra, and yes, I can tie the Old Testament into algebra too. Thank you very much. If you have an equation with two things on either side, what you do to one side, you have to do to the other. So I have to add 6 over here. If I divide by 5 on one side, I have to divide by 5 on the other side. What to do? I would like you to solve for x. You can solve this because it has an equal sign in it. So solve that for me. Go right ahead. Do this in one. Okay, let's see who's popular today. Who has a bid for the answer? What do you think, Alyssa? What do you think the answer is? -3? Who thinks it's -3? So we have a bid for x equals -3. Who thinks it is? Raise your hand again. Looks like you're decently popular. Does somebody have a different answer? What did you get? Nate?
3 over -2.
What?
3 over -2.
Who got 3 over -2? Or -3 over 2? Oh, you're very lonely today. I'm so sorry. Should we actually do this one out? Yeah, let's do this. So, what could we do on the left first? Yeah, so you end up with 2x minus 5 equals. What could you do on the right? Yeah, 7 plus what? What should I add to both sides at this point? What could I add to both sides? I could do a lot of things, but what should I do? I'm not going to add 2x to both sides. I'm not going to do that either. What can I add? I want to add something to both sides. Add 5. Thank you, Katie. So what do I end up with? 2x equals 12 plus 6x. Now what should I subtract from both sides? 6x? So what do I get on the left if I subtract 6x? So you get -4x equals. Now what do I do? Divide both sides by -4 and you end up with x equals -3. Nice. Yeah. What's the only thing that's slightly different about this one? Fractions! Yay! We love fractions! So you multiplied both sides by 6. I like that. So you do get... Okay, I see this. Now I have a question for you. Right here. So this did turn into that. I like that. That's good. And then this... Wait. I guess, why did it turn into x minus 7? Okay, so it should be x plus 7. Okay. Oh, okay. But then my question is, what about this term right here?
I have times it by 2.
Golden rule of algebra, what you do to one side, you have to do to both sides. But if you multiply this one by 6 on this side, what else do you have to multiply by 6? You have to multiply the 2x squared. It's not you have to multiply the 2x minus 8 over 2 by 6 as well. If you multiply one thing on one side by 6, you have to multiply everything on that side and everything on the other side by 6. So multiplying by 6, love that maneuver. You just have to take this. I'm going to cross that out right there. And we're going to multiply. We have to multiply that by 6 as well. But here's the thing. What's 6 divided by 2? So you can cancel that. It becomes 3. So what is this? X plus 7 plus 3 times 3x minus 8 equals, not doing this yet, -24. When you multiply by 6, are all the fractions gone? All the fractions are gone right now. We have no fractions left. Is this a lot easier? Plus what?
It's 2x.
2x? Oh, thank you. It is 2x right there. Thank you. Is this a lot easier to solve? Yes. Yep. If you do this one out right here, what should I do first? What word? Give me one word. What can I do? Right here. What can I do?
The bracket.
Yeah, what's that called? What operation? What? Distribute. Yeah. So you get x plus 7 plus
6x
minus negative 24. What like terms could we combine on the left?
x.
And?
6x.
Yeah, so you get 7x plus 7 minus 24 equals... Oh, what can we cancel on both sides, just because they're on both sides? The negative 24. So you get 7x is equal to negative what?
7.
So x is equal to?
Negative 1.
Yeah, good job. They are going to be called conditional equations because they are true some of the time under certain conditions. For example, this equation right here, is this a conditional equation? This equation is true when what? When x is, what was it? 4. This is true when x is 4. Is it true at any other time? No. So it's true under the condition that x is equal to 4. Okay, so those are most of the ones we're going to see. But what about the other ones? So this is conditional true true under some circumstances. What about the other ideas? If it's true under some circumstances, it could also be true under all circumstances, or not true. So let's do the not contradiction. What about contradiction? It seems like it'd be silly, but like, what about this? 6x. Oh, how about this? Contradiction. How about x plus 3 is equal to x plus 2? Is that ever true? If you subtract x from both sides, you end up with 3 equals 2. Is that true? No, that's a contradiction. So contradiction is no solutions. Now, what about identity, though? What about identity? So you have under some circumstances, no circumstances, and then what would the next one be? All circumstances. So here's one. It looks silly, but how about this? 2x is equal to 2x. When is that true?
Always.
Any real value for x, exactly, right? Now, someone in the last class said, well, that's just silly. Why would you? It's just automatic. You know that, right? But sometimes it's not that obvious. I'm going to change things one at a time. Is this the same thing? Is that the same thing?
Yeah.
What about this? All I'm doing is adding, I added 3 to both sides. But is it, yeah, it's still the same thing, right? But does it look obvious? It's less and less obvious, right? So sometimes means conditional is sometimes true. Contradiction means never true. And contradiction means, identity means always true, no matter what you plug in. So if you're cruising around on an equation and you end up with 6 equals 9, sometimes that's going to mean you made a mistake. But sometimes it's also going to mean it's a, what kind of equation? Contradiction. 6 equals 9 is not true, so it's going to be a contradiction. Okay, so what about formulas and percents? You've seen mathematical models before, and these are an equation or inequality. These inequations are qualities that model something in real life. Some of you may have taken some physics or seen some of these equations. What does distance equal? Rate times time. What about the area of a circle? Anybody remember? Pi r squared. What about the area of a rectangle? Length times width, right? What about the area of a triangle? 1/2 base times height. 1/2 base times height divided by 2. Sure. These are all mathematical models. They are equations that describe a real situation. Sometimes you're going to want to isolate one of the variables. Sometimes. For example, do you remember circumference? What is it? What is it? Remind me. And diameter is 2 times r, right? So 2 pi r. Well, that's circumference in terms of r, radius. What happens if I wanted radius in terms of circumference? What would I have to do? Divide by 2 pi. So radius is equal to c over 2 pi. Exactly. So that you can plug circumference into, and what do you get out? Radius. This one right here, you plug in radius, and what do you get out? Circumference, the opposite. Exactly. So sometimes you're going to need to isolate. So what are you going to do? It's similar to what we just did before. you're going to get rid of fractions, put everything with the variable you want on one side, and then divide. Whee! It's a good time. What about percents? Have you dealt with percents before? Yeah. So what about A right there? 50-liter mixture of acid and water contains 10 liters of acid. What percentage of it is acid? What percentage of that is acid? How'd you get 20%?
10.
How'd you get 1/5? Yeah, it's what you're doing the percentage of over the total volume, right? And that's, in this case, 50. So it's 10 over 50, which is 1 over 5, which is 0.2, which is 20%. There's a lot of, you don't have to write this out every time, but 1/5 is 20% because 1/5 written as decimal is 0.20. What about this? Let's make it a little bit more fun. You can use your calculator to do this because you probably don't know the division. But without talking to anybody, try doing that question right there. Can someone define what is markup?
Increase.
Increase. The increase is going to be 1464 minus what?
1,200.
And then divide it by what?
1,200.
Yeah, this is that right there is the base price. And then what's this? That's the markup. So what's that going to be?
264.
Yeah, over 1,200, and that's why you need your calculator. And it comes out to 0. What? 2. Keep going. Is it exactly 22?
Yeah.
It is?
Yeah.
Wow, cool. So what does that mean?
22%.
22%.